So, drawing Lewis diagrams for polyatomic ions is really similar to drawing Lewis diagrams for other molecules. It just has one or two extra steps. So, a polyatomic ion, those are the groups of covalently bonded atoms that have a single charge. In ammonium, that single charge is that positive. In sulfate, it's that 2 negative. In nitrate, it's that negative. And so those single charges represent a gain or like a loss of an electron. And so that positive, since electrons are negatively charged, means that it has one less electron than usual. In sulfate, that 2 minus means that there's 2 more electrons because it has a negative charge. In nitrate, that negative is essentially a 1 negative, so it has 1 more electron to be counted when you're when you're calculating the valence electrons for your structure. And so that charge, it only really impacts the valence electrons in the structure. The rest of the process is the same. For example, ASO3, 3 minus, you count your valence electrons as you usually would. You put arsenic, oxygen, oxygen, oxygen. Arsenic is in group 15 and therefore has 5 valence electrons. Oxygen is in group 16 and has 6 valence electrons. But since we have that 3 minus charge, we need to make sure that we add 3 electrons to that count of valence electrons that we're working with. And so that adds up to be 26 total valence electrons that we're working with. And so from here, you make your Lewis diagram as usual. So you put arsenic in the center with oxygen surrounding, and then you count out your 26 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And since arsenic has an expanded octet, it's beyond that third period, you can put those last 2 right up above there. And all 26 of your valence electrons have been used. And we're almost done. All we need to do is to signify that it's an ion with these little brackets that go around it, and also a little 3 minus in the top right to signify that it's an ion. So all of our Lewis structures will have that format. If it's an ion, if it was ammonium, it would have a little plus up there. Sometimes it'll just be a minus, maybe it'll be a 2 minus. But that's just the format that we are always going to have with ions. Another example, ClO2 minus. Start counting your valence electrons as usual. You have chlorine, oxygen, oxygen, and chlorine is in that 17th group, and so it has 7 valence electrons. Oxygen has 6, and that little minus means that we have to count 1 extra electron, and the sum of those is 20 valence electrons. And so when we're making our Lewis structure, as usual, chlorine is in the center as it's listed first, and oxygen is surrounding. And then we start counting out those 20 again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And since chlorine can have that expanded octet, 17, 18, 19, 20. All 20 of our valence electrons are used. Now all we have to do is signify it's an ion with the brackets and the minus in the upper hand right corner. And so because it's an ion, we don't have to draw any of these dipole arrows that we usually would. And otherwise, you're all done.